press the bell icon on the YouTube app and never miss another update.
Hello students, welcome to part 13 of the chapter Alcohols, Phenols and Ethers. Last theoretical part in this chapter, some properties of ethers. In the last class, we have discussed the preparations of ethers by the dehydration of alcohols and also by Williamson's ether synthesis method. ಅಲ್ಲಿ ಎರಡು very important points ಇದಾವೆ, ಅದನ್ನು ಕರೆಕ್ಟಾಗಿ ಜ್ಞಾಪಿಟ್ಟುಕೊಂಡ್ರೆ. In Williamson's ether synthesis method, both symmetrical and unsymmetrical ethers can be prepared starting from alkyl halides and sodium alkoxides. But during the preparations of ethers containing substituted alkyl groups, alkyl halide should be primary. Alkyl halide should be primary. If secondary or tertiary alkyl halides are used, elimination reaction competes over nucleophilic substitution reactions because the nucleophilic attack that becomes very difficult. So because there is a hindered groups are there in secondary and tertiary alkyl halides. So that is why in such cases, if secondary and tertiary alkyl halides are used, alkoxide ion cannot act as a nucleophile, that can act as a base. So that is why that leads to the formation of alkenes. Elimination reaction competes over nucleophilic substitution reactions when secondary or tertiary alkyl halides are used in or in the preparation of substituted ethers. Is clear? ಅದೊಂದು ಪಾಯಿಂಟನ್ನು ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಿಟ್ಟುಕೊಂಡ್ರೆ, ಅದಕ್ಕೆ ನಾನು ಎರಡು ಎಕ್ಸಾಂಪಲ್ಸ್ ನಿಮಗೆ ಕೊಟ್ಟಿದ್ದೇನೆ. ಒಂದು, ಈ ಟರ್ಷರಿ ಬ್ಯೂಟೈಲ್ ಮೀಥೈಲ್ ಈಥರ್ ಪ್ರಿಪೇರ್ ಮಾಡಬೇಕಾದ್ರೆ ಮೀಥೈಲ್ ಹ್ಯಾಲೈಡ್ ಸೋಡಿಯಂ ಟರ್ಷರಿ ಬ್ಯೂಟಾಕ್ಸೈಡ್ ಯೂಸ್ ಮಾಡಬೇಕು. ಮೀಥೈಲ್ ಹ್ಯಾಲೈಡ್ ಅದು ಪ್ರೈಮರಿ ಅಲ್ಕೈಲ್ ಹ್ಯಾಲೈಡ್ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಈಥರ್ ಕಂಟೈನಿಂಗ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಟೆಡ್ ಅಲ್ಕೈಲ್ ಗ್ರೂಪ್ಸನ್ನು ನೀವು ಪಡಿಬೋದು. ಸಪೋಸ್ ಇನ್ನೂ ಒಂದು ಕೂಡ ಹೇಳಿದ್ದೆ, ಟರ್ಷರಿ ಬ್ಯೂಟೈಲ್ ಬ್ರೋಮೈಡ್ ವಿತ್ ಸೋಡಿಯಂ ಈಥಾಕ್ಸೈಡ್. ಟರ್ಷರಿ ಬ್ಯೂಟೈಲ್ ಬ್ರೋಮೈಡ್ ಸೋಡಿಯಂ ಈಥಾಕ್ಸೈಡ್ ತಗೊಂಡಾಗ ಸೋಡಿಯಂ ಈಥಾಕ್ಸೈಡ್ ಕೆನಾಟ್ ಆಕ್ಟ್ ಆಸ್ ಎ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್. ಟರ್ಷರಿ ಬ್ಯೂಟೈಲ್ ಬ್ರೋಮೈಡ್ಲಿ ಹಿಂಡೆಡ್ ಗ್ರೂಪ್ಸ್ ಇದ್ದಾವೆ. ಸೊ ಹಾಗಾಗಿ ಅಲ್ಲಿ ಮೀಥಾಕ್ಸೈಡ್ ಆ್ಯಡ್ ಏನಿದೆ ದಟ್ ಕ್ಯಾನ್ ಆಕ್ಟ್ಸ್ ಆಸ್ ಎ base, so that the tertiary butyl bromide undergoes elimination reaction that leads to the formation of alkenes. ಅದೊಂದು ಪಾಯಿಂಟನ್ನು ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಿಟ್ಟುಕೊಂಡ್ರೆ. So today I am going to discuss some properties of ethers. So we know that ether functional group is less reactive. So when compared to alcoholic groups, aldehyde, ketones, carboxylic acids and haloalkanes, so this is the less reactive functional group. That is why only few chemical properties are there for ethers. Is it clear? So ಹಾಗಾಗಿ ಇಲ್ಲಿ ಕೆಲವು ಪ್ರಾಪರ್ಟೀಸ್ ಇದ್ದಾವೆ. ಒಂದು, ರಿಯಾಕ್ಷನ್ ಆಫ್ ethers with HBr or HI, strong acids. Another property is electrophilic substitution reactions. So for anisoles, aromatic ethers. So ಅದರಲ್ಲಿ ಒಂದು ಬ್ರೋಮಿನೇಷನ್ ಇದೆ, Friedel-Crafts alkylation ಇದೆ, Friedel-Crafts acylation reactions and nitration. ಒಂದು 4 ಪ್ರಾಪರ್ಟೀಸ್ ಇದ್ದಾವೆ. ಸೊ ಅಲ್ಲಿಗೆ ಈ ಟಾಪಿಕ್ಕು ಥಿಯರಿಟಿಕಲ್ ಪಾರ್ಟ್ ಕಂಪ್ಲೀಟ್ ಆಗುತ್ತೆ. ಇನ್ನು ನಿಮ್ಮ ಕೆಲಸ ಅದೆಲ್ಲ ಒಂದು ಸರಿ ಕರೆಕ್ಟಾಗಿ ರಿವೈಸ್ ಮಾಡಿಕೊಂಡ್ರೆ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಿಂದ ನಿಮಗೆ ಕಾಂಪಿಟೇಟಿವ್ ಪಾರ್ಟಿ ಮಾಡೋಣ. ನೋಡಿ, ಸೊ ಇನ್ ಕೇಸ್ ಆಫ್ ಈಥರ್ಸ್ ಇಲ್ಲಿ 2 ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟಿ ಇದ್ದಾವೆ. ಸೊ ಒಂದು ಮಿಸಿಬಿಲಿಟಿ, ಇನ್ನೊಂದು ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್. ಸೊ ಇನ್ ಕೇಸ್ ಆಫ್ ಈಥರ್ಸ್, ಸೊ ROR, this is a polar group, the CO bond. So this CO bond is polar. So due to difference in the electronegativity values, but weak polarity. So this polarity is a weak polar nature. So weak polarity, due to weak polarity in case of ethers, there should be a net dipole moment due to weak polarity. So there is a net dipole moment. Dipole moment. So it is the product of charge and distance between them. ಇಲ್ಲಿ ಪೊಲ್ಯಾರಿಟಿ ಇರೋದ್ರಿಂದ ನೆಟ್ ಡೈಪೋಲ್ ಮೂಮೆಂಟ್ ಅನ್ನು ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡ್ತೀರಿ. ಅಂದರೆ ದೇ ಆರ್ ನಾಟ್ ಲೀನಿಯರ್ ಮಾಲಿಕ್ಯೂಲ್ಸ್. ನಾನು ಹೇಳಿದ್ದೆ ಇನ್ ಕೇಸ್ ಆಫ್ ಈಥರ್ಸ್ ಬಾಂಡ್ ಆ್ಯಂಗಲ್ ಅಲ್ಲಿ ಹೇಳಿದ್ದೆ 111.7 ಡಿಗ್ರಿ ಜ್ಞಾಪಕಿದೆಯಲ್ವಾ? ನೋಡಿ ಅದನ್ನು ಚೆನ್ನಾಗಿ ಜ್ಞಾಪಿಟ್ಕೊಳ್ರಿ. ಸೊ is due to weak polarity of the CO bond in case of ethers, it does not affects effectively on their boiling points. So we know that the boiling point of carbonyl compounds, it is due to its polarity. Is it clear? Higher boiling point of alcohol is due to intermolecular hydrogen bonding. So that is why here also due to weak polarity. So because of this weak polarity in case of ethers, it does not affects on their boiling points. So when compared to hydrocarbons, say for example CH3, CH2, so 3 times CS3, this is N-pentane, and if you take CH3, CH2O, CS2, CS3, and then butanol, CS3, CH2, CH2, CS2OH, CS2OH. So here there is a less polarity in case of ethers, but here no polarity. So as the molecular size increases the van der Waals force, that is why there is no much difference in the boiling points of these two. So almost same boiling points of this ether and N-pentane is clear. So but in case of N1-butanol, so there is a large difference in their boiling point. So large difference in their boiling points, it is due to intermolecular hydrogen bonding. Intermolecular hydrogen bonding among themselves in case of alcohols, but there is no intermolecular hydrogen bonding in case of ethers. That is why ethers have lower boiling points. There will be a large difference in the boiling points of both ethers and alcohols. Alcohols have higher boiling points due to intermolecular hydrogen bonding, but ethers have lower boiling points. But among these two, the difference in their boiling points, it becomes very much less. So here around 309 Kelvin. So here 307.6 degree Kelvin, nearly 308 Kelvin. So 306.7. So here 306.7 Kelvin. But in case of butanol, 1-butanol, around 390 Kelvin is there. So these are the boiling points of hydrocarbons, ethers and alcohols. So difference in the boiling points between these two, it becomes very large because of the existence of intermolecular hydrogen bonding in case of alcohols, but no intermolecular hydrogen bonding can be observed in case of ethers. That is why they have lower boiling points than alcohols. But among these two, so there will be a very less polarity in case of ethers. So that is why, so when compared to the molecular mass, comparable molecular mass of these hydrocarbons, they have almost same. Means the difference, it becomes very much less. And also the diethyl ether. So diethyl ether, C2H5O, C2H5. And also CH3, CH2, CH2, CH2OH. So they have both are having same molecular formula, same molecular mass, but they exist in two types of different functional groups. So one is ether and other one is alcohol. So here its boiling point is low, its boiling point is high. but their miscibility, solubility with water, ನೋಡಿ ಅಬ್ಸರ್ವ್ ಮಾಡ್ರಿ, ಸಾಲ್ಯುಬಿಲಿಟಿಯನ್ನು ನೋಡಿದಾಗ ಸೊ ಆಲ್ಮೋಸ್ಟ್ solubility that remains same as that of alcohols. Solubility or miscibility with water of ether resembles with those of alcohols. It is due to, ನೋಡಿ ಯಾಕೆ ಹಾಗಾದರೆ ಸೇಮ್ ಸೊ ವಿಸಿಬಿಲಿಟಿ ಅಂದರೆ ಸಾಲ್ಯುಬಿಲಿಟಿ ಈ ವಾಟರಲ್ಲಿ ಕರೆಕ್ಟ್ ಆಗ್ತಕ್ಕಂಥದ್ದು ಇದಕ್ಕೆ ಎಷ್ಟಿದೆಯೋ ಇದಕ್ಕೆ ಆಲ್ಮೋಸ್ಟ್ ಅಷ್ಟೇ ಇದೆ. ದ ರೀಸನ್ ಈಸ್ ಸೊ ಇಟ್ ಕ್ಯಾನ್ ಫಾರ್ಮ್ hydrogen bonding with water. This also forms hydrogen bonding with water. So ethers, so ROR, so ROR ether, then water. So water again HOH. So there is intermolecular hydrogen bonding so exists in between, in not among the ethers. ಈಥರ್ ಮಾಲಿಕ್ಯೂಲ್ಸಲ್ಲೇ ಆಗಲ್ಲ, ಇದು ಈಥರ್ ಲಿಕ್ವಿಡ್ ಅಂದರೆ ಸೊ ಇದರ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಅರೌಂಡ್ ನೋಡಿ ಎಷ್ಟಿದೆ ಇಲ್ಲಿ 273 ಅಂದರೆ 27 + 6 33 34 ಡಿಗ್ರಿ ಸೆಂಟಿಗ್ರೇಡ್ ಇದೆ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್. 34 ಡಿಗ್ರಿ ಅರೌಂಡ್ 35 ಡಿಗ್ರಿ ಸೆಂಟಿಗ್ರೇಡ್. ಇಸ್ ಕ್ಲಿಯರ್. ನಾನು ಹೇಳ್ತಕ್ಕಂಥದ್ದು ಸಾಲ್ಯುಬಿಲಿಟಿ ಕರಗ್ತಕ್ಕಂಥದ್ದು. ಸೊ ಈ ಕರಗಬೇಕಾದ್ರೆ ನೋಡಿ ವೈ ದಿ ಆಲ್ಕೋಹಾಲ್ಸ್ ಆಫ್ ಲೋಯರ್ members they are highly miscible with water andre due to the formation of an extensive hydrogen bonding, formation of intermolecular hydrogen bonding with water. Is clear? So like alcohols, ethers are also forms hydrogen bonding with water. That is why miscibility of ethers resembles with those of alcohols of same molecular mass. ಎರಡಕ್ಕೂ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್ ಒಂದೇ ಇದೆ, ಬಟ್ ಮಿಸಿಬಿಲಿಟಿ ಆಲ್ಮೋಸ್ಟ್ ಸೇಮ್ ಇದೆ. ಕರಗ್ತಕ್ಕಂಥದ್ದು ವಾಟ್ರಲ್ಲಿ ಡೈಥೈಲ್ ಈಥರ್ ಮತ್ತು 1-ಬ್ಯೂಟೆನಾಲ್ ಆಲ್ಮೋಸ್ಟ್ ಸೇಮ್ ರೇಟಲ್ಲಿ ಕರಗ್ತಾ ಇದ್ದಾವೆ. ಇಟ್ ಈಸ್ ಡ್ಯೂ ಟು ದಿ ಫಾರ್ಮೇಷನ್ ಆಫ್ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಹೈಡ್ರೋಜನ್ ಬಾಂಡಿಂಗ್ ವಿತ್ ವಾಟರ್. ಸೊ ಇದು ನಿಮಗೆ ಫಿಸಿಕಲ್ ಪ್ರಾಪರ್ಟೀಸಲ್ಲಿ ಬರ್ತಕ್ಕಂಥದ್ದು ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್. Ethers have lower boiling points than alcohols. Give reason anತಾರೆ, because ethers have inability to form hydrogen bonding among themselves. But alcohols due to the existence or due to the formation of intermolecular hydrogen bonding among the molecules of alcohols, therefore they have higher boiling points. Is clear? Next, so coming to the chemical properties of ethers. So first property is reaction with hydrogen halides. Reaction with hydrogen halides. Chemical properties. Chemical properties. So first property with HX. So it may be either HBr or HI is used. Stronger acids are used. So their reactivity of ethers are very much less. Low reactivity. It is a low reactive functional group. So which one? Ether. So when ethers ROR, this is the symmetrical ether. It is symmetrical ether. Symmetrical ethers. On heating with HX, it gives. So CO bond cleavage takes place. So one the kadege H, one the kadege X to form ROH plus RX. ROH plus RX. So limited HX is used. Limited hydrogen halide. Hydrogen halide means it may be either HBr or HI is used. So one is alcohol and other one is alkyl halide. Alkyl halide. Is clear? Or if A or OR, this is alkyl aryl ethers. So these are called alkyl aryl ether when it is heated with HX to form. In this case, this CO bond means the phenoxide group, it is highly stable. This bond cannot be broken. So that is why the alkyl oxygen bond breaks takes place. Alkyl oxygen, the carbon of alkyl group and oxygen atom bond breaks occurs. This results in the formation of AROH and RX to form AROH plus RX. So this is phenol and alkyl halide. So reason is phenoxide ion ARO bond is more stronger because phenoxide ion is more stable. ಇಲ್ಲಿ ಆ್ಯಕ್ಚುಲಿ ಏನಂದರೆ ಕಾನ್ಸೆಪ್ಟನ್ನು ನೋಡ್ರಿ ಹೇಗಾಗ್ತದೆ ಅಂತಂದರೆ, ಇನ್ ದಿಸ್ ಕೇಸ್ ಇಟ್ ಅಂಡರ್ಗೋಸ್ protonation. So lone pair of electrons on the oxygen atom in case of ether, so it can donate to this H plus, means which can accept proton to form protonated ether, or in other words oxonium ion. Next one is this X, which attacks to the less substituted alkyl group, less hindered alkyl group. Is clear? Or smaller alkyl group that results in the formation of alkyl halide. ಸೊ ಇಲ್ಲಿ ನಿಮಗೇನು ಗೊತ್ತಾಗೋದಿಲ್ಲ, ಇದು ಸಿಮಿಟ್ರಿಕಲ್ ಈಥರ್ಸ್ ತಗೊಂಡಾಗ. ಇಸ್ ಕ್ಲಿಯರ್? ಸೊ ಎಕ್ಸಾಂಪಲ್ ನಾನು ಮುಂದೆ ಕೊಡ್ತೇನೆ, ಡೀಟೇಲಾಗಿ ಹೇಳ್ತೇನೆ ನಿಮಗೆ. ಡೈ ಈಥೈಲ್ ಈಥರ್ C2H5 OC2H5 CTH5 OCTH5. So when it is heated with hydriodic acid to form, so here also, so limited quantity of HI is used at lower temperature. So CO bond strength that always remains same because both the groups are same, identical alkyl groups are there. So one of the CO bond breaks, done. So here I, here H, so we get ethyl alcohol and ethyl iodide. Ethyl alcohol C2H5OH plus C2H5I. So we get ethanol or ethyl alcohol and ethyl iodide. Ethyl alcohol and ethyl iodide, mixture of alcohol and alkyl iodides are formed when symmetrical ethers or simple ethers reacts with limited quantity of HI. Limited quantity of HI. So if excess of HI is used, so in this case, instead of limited quantity of HI, if excess of HI is used, so which reacts with the obtained ethanol, and once again they converted this ethanol to ethyl iodide. So the reaction occurs like this: C2H5O C2H5 with excess HI, at higher temperature to form. So it involves 2 moles of HI. 2 moles of HI. So bond breaks occurs like this. So here, so one I, here also I, H, HI, again HI. So this results in the formation of CTH5I and H2O. C2H5I, 2 moles plus H2O. So we get only ethyl iodide. Yavaga? When diethyl ether is heated with excess of hydriodic acid. When excess of hydriodic acid or hydrobromic acid is used. ನೋಡಿ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ನೀವು ಎಕ್ಸಸ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಇನ್ ದಿ ಫಸ್ಟ್ ಸ್ಟೇಜ್ ವಿ ಗೆಟ್ ethyl iodide and ethanol. This obtained ethanol, once again it reacts with another molecule of HI. ಆ HI ನಲ್ಲಿ H ಈ OH ವಾಟರ್ ಆದರೆ ಇನ್ನು I ಇದಕ್ಕೆ ಅಟ್ಯಾಕ್ ಆಗುತ್ತೆ. ಸೊ ವಿ ಗೆಟ್ ಓನ್ಲಿ ದಿ ಅಲ್ಕೈಲ್ ಅಯೋಡೈಡ್ಸ್. ಇಲ್ಲಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ನೋಡಿ, ವೆನ್ ಈಥರ್ಸ್ ಆನ್ ಹೀಟಿಂಗ್ ವಿತ್ limited quantity of HI or with cold and dilute HI. So here cold and dilute HI. Limited cold and dilute hydrochloric acid is used, we get a mixture of ethyl alcohol and ethyl iodide. Instead of cold and dilute HI, so if hot and concentrated hydriodic acid in excess is used to give only the ethyl iodide. So if diethyl ether is heated with excess of hot and constant hydriodic acid is used, we get only the ethyl iodide. All conditions kodtara. When symmetrical ether on heating with limited quantity of HI, your answer is we get a mixture of alcohol and alkyl iodide. When symmetrical ether on heating with hot and concentrated hydriodic acid in excess, we get only the alkyl iodide, not alcohol. Only alkyl iodide is used. The next question arises, suppose if mixed ethers are used. Nodi, alli enagutte hagadre. So these points are, I think, these points are clear. ಅರ್ಥ ಮಾಡ್ಕೊಂಡ್ರಲ್ಲ. ಇಲ್ಲಿ ಎರಡೇ ಪಾಯಿಂಟ್, ಎರಡು ಸ್ಟೇಟ್ಮೆಂಟ್ ಏನೋ, ವೆನ್ ಸಿಮಿಟ್ರಿಕಲ್, ನಾನು ಅನ್ಸಿಮಿಟ್ರಿಕಲ್ ಈಥರ್ಸ್ ಆಮೇಲೆ ಬರ್ತೇನೆ. ವೆನ್ ಸಿಮಿಟ್ರಿಕಲ್ ಈಥರ್ಸ್ ಆನ್ ಟ್ರೀಟ್ಮೆಂಟ್ ವಿತ್ cold and dilute HI with limited quantity, we get a mixture of alcohol and alkyl iodide. So one point is over. When symmetrical ethers on heating with a hot and concentrated hydriodic acid in excess, we get only the alkyl iodide. ಇಲ್ಲಿ ಬರ್ತಕ್ಕಂಥದ್ದು ROH ಇದೆಯಲ್ಲ, ಮತ್ತು HI ಜೊತೆ ರಿಯಾಕ್ಷನ್, we get only alkyl iodide. If alkyl aryl ethers on heating with HI, so one of the important compound is phenol. So ಮತ್ತೆ ನೀವು ಇಲ್ಲಿ alkyl iodide, so aryl iodide and alcohol not possible. So ಅದಕ್ಕೆ ರೀಸನ್ ಮುಂದೆ ಕೊಡ್ತೀನಿ ನಾನು. So because this CO bond in phenoxide group is more stronger and also it is highly stable. So in case of phenols, phenoxide ion is more stable due to resonance. ಓದಿದಿರಿ. That is why this H plus it attacks to OR phenoxide group to form phenol, and halogen can form a bond with a smaller organic group. So we get alkyl iodide or alkyl halide and phenol. If aromatic ether like alkyl aryl ethers on treatment with HX, we get alkyl halide and phenol, not aryl halide and alcohol. This is one of the most important reaction. Is clear? Then, in case of unsymmetrical ethers, so reaction of ethers with HX, what is the order of reactivity of hydrogen halides towards ethers? Order of reactivity of HX is, so we know that HI is stronger acid than HBr than HCl. So that is why these are the stronger acids, and ether function group is a lower reactivity function group. So for this reason, HI and HBr are preferred, not HCl. Is clear? Then unsymmetrical ethers, ROR dash. So when it is heated with HX to form, ನೋಡಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ, ಸೊ ದಿ CO ಬಾಂಡ್ ಬ್ರೇಕ್ಸ್. ಯಾವ CO ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗುತ್ತೆ? ಈಸ್ ಆರ್ CO ಆರ್ ಡ್ಯಾಶ್ CO. Assuming that this is the lower alkyl group, then the bond breaks occurs like this. So halide ion can form a bond with lower alkyl group, and hydrogen atom can form a bond with RO group to form RH plus R dash OH. The condition is in case of unsymmetrical ether, when it is heated with HX in limited quantity, so halide ion can form a bond with smaller organic group, lower alkyl group. So X, it can form a bond with lower alkyl group. That results in the formation of Rx and R dash OH, not R dash X and ROH. ಇದು ಪಾಸಿಬಿಲಿಟಿ ಇಲ್ಲ. ನಾನು ಎಕ್ಸಾಂಪಲ್ ಕೂಡ ಕೊಡ್ತೇನೆ ಇಲ್ಲಿ. ಸೊ ಎಕ್ಸಾಂಪಲ್ CH3 CH2 OH, O CH3. This is ethyl, methyl, ether. When it is heated with hydriodic acid to form, it reacts with hydriodic acid to form. Among these two groups, this is the lower alkyl group. So which one? Methyl group. Hence, so this bond breaks like this, and this iodide ion, it can form a bond with the methyl group, and H can form a bond with oxygen atom to form ethyl alcohol CH3 CH2OH plus CH3I. It means that if primary or secondary alkyl groups are present, in such cases, halide ion can form a bond with lower alkyl group that can form alkyl halide. If tertiary alkyl halides are involved, then it follows SN1 reaction. It means that if ethers containing a tertiary alkyl group, adana example kodtene ನಾನು. If ethers containing a tertiary alkyl group, halide ion, it attacks to more stable tertiary carbocation that results in the formation of tertiary alkyl halide. Is clear? When the alkyl group is primary or secondary, in such cases, halide ion can form a bond with lower alkyl group. This is very, very important. So when mixed ethers on heating with HI, assuming that mixed ethers containing a secondary or primary alkyl groups, in such cases, halide ion can form a bond with lower alkyl group, less hindered alkyl group, or the lower carbon atom of oxonium ion. ನಾನು ಅಲ್ಲಿ ಮೆಕ್ಯಾನಿಸಮ್ ಬರೀತೀನಿ, ನಿಮ್ಗೆ ಅವಾಗ ಕ್ಲಿಯರ್ ಗೊತ್ತಾಗುತ್ತೆ. ಇಸ್ ಕ್ಲಿಯರ್? ಸೊ ಇದೊಂದು ಪಾಯಿಂಟ್ ಜ್ಞಾಪಕಟ್ಕೊಡ್ರಿ. ಸೊ when primary or secondary alkyl groups are present, halide ion can form a bond with lower alkyl group. So results in the formation of alkyl iodide. Is clear? ಇದಕ್ಕೆ ಒಂದು ಎಕ್ಸಾಂಪಲ್ ಕೊಡ್ತೀನಿ ನೋಡ್ರಲೆ. So when methyl ethyl ether, so in this case ನೋಡಿ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡ್ರಿ, ಏನು methyl iodide ಫಾರ್ಮ್ ಆಗಿದೆ, ದೆನ್ ethyl ಆಲ್ಕೋಹಾಲ್ ಫಾರ್ಮೇಷನ್ ಆಗಿದೆ. methyl iodide and ethyl alcohol formation ಆಗಿದೆ ನೋಡಿ. ethanol and methyl iodide is formed. So among these two, so this is a smaller alkyl group or lower alkyl group. Halide ion can form a bond with lower alkyl group, that resulting in the formation of methyl iodide and ethanol. See the mechanism ಅನ್ನು ನೋಡ್ರಿ. In the first stage, it reacts with ethyl methyl ether, it undergoes protonation. It undergoes protonation. ನೋಡಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ. CH3, CH2, OCH3. So which reacts with HI to form. Suppose in case limited HI ಯೂಸ್ ಮಾಡಿದರೆ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ H ಪ್ಲಸ್ ಇದೆ I ಮೈನಸ್ ಇದೆ. ಸೊ ದಿಸ್ ಲೋನ್ ಪೇರ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಯುಟಿಲೈಸ್ ಇನ್ ದಿ ಫಾರ್ಮೇಷನ್ ಆಫ್ ಅ ಬಾಂಡ್ ವಿತ್ H ಪ್ಲಸ್ ಟು ಫಾರ್ಮ್ CH3, CH2, O plus H as it is, bond CH3 plus I minus. This is called the protonated ether, or it is also called oxonium ion. This is called oxonium ion or protonated ethyl methyl ether. ಇದು oxonium ion ಅನ್ನೋದು ಜನರಲ್ ವರ್ಡ್ ಇದು. If it undergoes protonation giving protonated ethyl methyl ether or oxonium ion. In the second step, so we know that it is a good attacking oxidizing agent or it is a good attacking reagent. Iodide ion is a good attacking reagent. So that in the second step, so CH3, CH2, O plus as it is H, so CH3, so plus I minus. So here it attacks two. So among the ethyl and methyl group, so in this case this is the less hindered carbon atom of the alkyl group. A nucleophile or iodide ion attacks to the less hindered alkyl or the less hindered carbon atom of the oxonium ion. This is oxonium ion. This is less hindered carbon atom of oxonium ion. So it attacks to this methyl group, and at the same time this oxygen atom gets the bonding electrons to form CH3, CH2, OH and methyl iodide and CH3I. So we get ethanol and methyl iodide. Is clear? Then again, if excess HI is used, again this ethanol CH3, CH2, OH, again it reacts with HI, so it undergoes protonation to form CH3, CH2, OH2, protonated ethyl alcohol and I minus. Then again it is a good oxidizing agent. It is a good attacking species. So that is why this iodide ion which attacks to, so CH3, CH2, CH2, so OH2 plus. So this I minus attacks to this CH2 group. At the same time, this OH2 group gets the bonding electrons to form CH3, CH2I, ethyl iodide and water and H2. So finally we get ethyl iodide. Yavagidu? When excess of hydriodic acid is used. ಸೊ ನಾನು ಹೇಳಿದೆ ಜನರಲ್ ರಿಯಾಕ್ಷನ್. ಸೊ ROR with HI, limited HI. So sorry, excess HI. So excess HI, it gives, so ನೋಡಿ ಇಲ್ಲಿ ಎರಡೂ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗುತ್ತೆ. ಸೊ IH again IH to form 2 moles of Ri plus H2O. 2 moles of Ri plus H2O. So here, if excess of HI is used, so in this case, so 1 molecule of methyl iodide is used. So this is unsymmetrical ether. So ಇಲ್ಲಿ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗುತ್ತೆ. H2O, methyl iodide, ethyl iodide. In this case, methyl iodide is obtained. Again, if excess of HI is used, this obtained ethanol reacts with HI to form protonated ethanol. This protonated ethanol, it is attacked by a nucleophile like I minus to form ethyl iodide. ನೋಡಿ ಹಾಗಾರಲ್ಲಿ, ಸೊ ಇಲ್ಲಿ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗುತ್ತೆ, ಇಲ್ಲಿ ಬಿ ಬಾಂಡ್ ಬೇಕಾದ್ರೆ methyl iodide along with the formation of water. If limited quantity of HI is used, we get only methyl iodide and ethanol. So this is also very important property. Is clear? ನೋಡಿ, ಎಕ್ಸಸ್ HI ಯೂಸ್ ಮಾಡಿದ್ರೆ ಫರ್ದರ್ ರಿಯಾಕ್ಷನ್ ಆಗುತ್ತೆ, ಇಲ್ಲಾಂದ್ರೆ ರಿಯಾಕ್ಷನ್ ಸ್ಟಾಪ್ ಆಗುತ್ತೆ. ಇಲ್ಲಿಗೆ ಈ ರಿಯಾಕ್ಷನ್ ಈ ಸ್ಟೇಜ್ ಸ್ಟಾಪ್ ಆಗ್ಬಿಡುತ್ತೆ. ಯಾಕೆ? ನೋ HI ಈಸ್ ಯೂಸ್ಡ್. ಇಫ್ excess HI is used, so further reaction takes place. This obtained ethanol, it undergoes again protonation to form protonated ethanol. Then it is attacked by, in the second step, it is attacked by I minus, results in the formation of ethyl iodide. Is clear? ಯಾವಾಗಿದು excess of HI is used. Suppose in case if ether containing tertiary alkyl group, in such cases iodide ion or halide ion, it can form a bond with the tertiary carbocation, or it can form a bond with tertiary carbon atom of the alkyl group in case of mixed ethers. Is clear? So ಹಾಗಾದ್ರೆ ಇಲ್ಲಿ iodide attack ಆಗಿದ್ದಂದ್ರೆ this reaction follows SN2 mechanism. So this is follows SN2 reaction. This reaction follows SN2 reaction. If tertiary alkyl group and another alkyl group is attached to oxygen atom in case of ethers, or in other words, ether containing tertiary alkyl group, in such cases halogen can form a bond with tertiary alkyl group. ನೋಡಿ ಅಲ್ಲಿ ಯಾಕೆ ಹಾಗಾಗುತ್ತೆ ನೋಡಿ, ಇಲ್ಲಿ ಗೊತ್ತಾಯ್ತಲ್ಲ, ಇದು ಲಿಮಿಟೆಡ್ ಕ್ವಾಂಟಿಟಿ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ, ಎಕ್ಸಸ್ ಯೂಸ್ ಮಾಡಿದ್ರೆ ಏನಾಗುತ್ತೆ ಅನ್ನೋದು. Then if tertiary alkyl group is present in ether, if tertiary alkyl group is present in ether, then halide ion can form a bond with tertiary alkyl group. So very important bond. If tertiary alkyl group is present in ether, then iodide ion or halogen can form a bond with, then halogen can form a bond with tertiary alkyl group results in the formation of tertiary alkyl halide. So it follows SN1 reaction. SN1 reaction. So example is, CH3, say CH3, OCH3 or CS2, CS3 or CS3. This is tertiary butyl methyl ether. This is the tertiary butyl methyl ether. So when it is heated with HI, so in the first stage it undergoes protonation. So the lone pair of electrons on the oxygen atom of this ether, it can form a bond with this proton to form CH3. So here CH3, CS3, so O plus HCS3, and along with I minus. So look at this oxonium ion. ನೋಡಿ ಇಲ್ಲಿ ಎರಡು ಪಾಸಿಬಿಲಿಟಿ ಇದೆ. ಹಾಗಾದ್ರೆ ಈ ಅಯೋಡೈಡ್ ಅಯಾನ್ ಇಲ್ಲಿಗೆ ಅಟ್ಯಾಕ್ ಆಗಬೇಕೋ ಅಥವಾ ಈ ಅಯೋಡೈಡ್ ಅಯಾನ್ ಇಲ್ಲಿಗೆ ಅಟ್ಯಾಕ್ ಆಗಬೇಕೋ? ನಾನು ಇಂದು ಪ್ರೀವಿಯಸ್ ಕೇಸಲ್ಲಿ ಹೇಳಿದೆ, ಇಫ್ ಈಟ್ ಮಿಕ್ಸ್ಡ್ ಈಥರ್ಸ್ ಕಂಟೈನಿಂಗ್ ಪ್ರೈಮರಿ ಆರ್ ಸೆಕೆಂಡ್ alkyl ಗ್ರೂಪ್ಸ್, ಇಫ್ ಮಿಕ್ಸ್ಡ್ ಈಥರ್ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಇಸ್, ಯಾಕಂದರೆ ನಿಮ್ಮ ಕಾಂಪಿಟೇಟಿವ್ ಪಾರ್ಟಲ್ಲಿ ಬರೀ ಇದ್ರ ಮೇಲೆ ಸರ್ ನಿಮಗೆ ಇಲ್ಲಿವರೆಗೆ ಕ್ವಶನ್ಸ್ ಬಂದಿರೋದು, ಯಾಕಂದ್ರೆ ಪ್ರಾಪರ್ಟೀಸೇ ಕಡಿಮೆ ಇಲ್ಲ. ನೋಡಿಲ್ಲಿ, ಇಫ್ ಈಥರ್ ಕಂಟೈನಿಂಗ್ ಪ್ರೈಮರಿ ಆರ್ ಸೆಕೆಂಡರಿ alkyl ಗ್ರೂಪ್ಸ್, halide ion can form a bond with lower alkyl group, can form alkyl halide. If tertiary alkyl group is present in ether, halide ion can form a bond with more stable tertiary carbocation. ನೋಡಿ ಸೆಕೆಂಡ್ ಸ್ಟೇಜಲ್ಲಿ ಏನಾಗುತ್ತೆ ನೋಡಿ, ಅಬ್ಸರ್ವ್ ಮಾಡಿದ್ರೆ in the second step CH3 so O plus H CH3 so plus I minus iodide ion. ನೋಡಿ ಇಲ್ಲಿ ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಸಪೋಸ್ ಈ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗಿ ಈ ಅಯೋಡೈಡ್ ಅಟ್ಯಾಕ್ ಆಗ್ಬೇಕ್ರಿ, ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗಬೇಕಾದ್ರೆ ಏನಾಗಬೇಕು ನೋಡಿ, ಮೀಥೈಲ್ ಕಾರ್ಬೋಕ್ಯಾಟೈನ್ ಜನರೇಟ್ ಆಗಬೇಕು. ಸಪೋಸ್ ಇನ್ ಕೇಸ್ ಈ ಬಾಂಡ್ ಬ್ರೇಕ್ ಆಗಬೇಕಾದ್ರೆ ಟರ್ಷರಿ ಕಾರ್ಬೋಕ್ಯಾಟೈನ್ ಜನರೇಟ್ ಆಗಬೇಕು. ಅಮಾಂಗ್ ಮೀಥೈಲ್ ಕಾರ್ಬೋಕ್ಯಾಟೈನ್ and tertiary carbocation, which one is more stable? Tertiary carbocation is more stable. So here actually the second step is the formation of carbocation. ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ ನೋಡಿ, ಮೇಜರ್ ಇಲ್ಡ್ ಟರ್ಷರಿ ಕಾರ್ಬೋಕ್ಯಾಟೈನ್ ಬರುತ್ತೆ. ಸೊ ವೆರಿ ಲೀಸ್ಟ್ ಪರ್ಸೆಂಟೇಜ್ ಅಲ್ಲಿ ಮೀಥೈಲ್ ಕಾರ್ಬೋಕ್ಯಾಟೈನ್. ಸೊ ದಟ್ ಈಸ್ ವೈ ದಿಸ್ iodide ion ಕ್ಯಾನ್ ಫಾರ್ಮ್ ಎ ಬಾಂಡ್ ವಿತ್ ದಿಸ್ ಟರ್ಷರಿ ಕಾರ್ಬೋಕ್ಯಾಟೈನ್. ದೆನ್ ದಿಸ್ ಬಾಂಡಿಂಗ್ electrons are comes over here. This results in the formation of tertiary butyl iodide, and along with methanol, so methyl alcohol. So this is very important property. ಯಾಕೆಂದ್ರೆ ನೋಡಲಿ, so look at this statement. If tertiary alkyl group are present in ether, halogen can form a bond with tertiary alkyl group. Tertiary alkyl group results in the formation of tertiary alkyl halide. So it follows SN1 reaction. Since 3-degree carbocation or tertiary carbocation formed is more stable. That is why halide ion particularly attached to tertiary carbon atom of this oxonium ion results in the formation of tertiary butyl iodide. Is clear? So ಇದು ಒಂದು ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್ ಜ್ಞಾಪಕಮಾಡಿ. Mixed ethers containing primary or secondary alkyl groups are present. Then halogen can form a bond with lower alkyl group. Results in the formation of alkyl iodide. And another one, alcohol. If mixed ether containing tertiary alkyl group, halogen can form a bond with tertiary alkyl group because tertiary carbocation is more stable. So that is why the halide ion it can attach to the more stable tertiary carbocation, results in the formation of tertiary butyl iodide. So this is tertiary butyl iodide. Is clear? So this is very, very important point. Then another properties, electrophilic substitution reactions. Second property, ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರೋಫಿಲಿಕ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ರಿಯಾಕ್ಷನ್ಸ್ ಅಲ್ಲಿ 3 ಪ್ರಾಪರ್ಟಿ ಬರುತ್ತೆ, ಎಲ್ಲ ಒಂದೇ ಥರ ಇದ್ದಾವೆ ನೋಡಿ. ಎಲೆಕ್ಟ್ರೋಫಿಲಿಕ್ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ರಿಯಾಕ್ಷನ್ಸ್. Second property, electrophilic substitution reactions. Particularly for aromatic ethers. So for aromatic ether like anisole. So in general we know that electrophiles preferably attach to the centers having high electron density. This explanation is very similar to the electrophilic substitution reactions of phenol. Phenol alli ಏನು ಹೇಳಿದ್ರು ಅದೇ ಪ್ರಾಪರ್ಟಿ. Phenol containing OH group, that is electron donating group, that increases the electron density at ortho and para position. So therefore in case of aromatic ethers also, so look at the resonating structures of this aromatic ether. So this is OR, this is alkyl aryl ether, so which contains oxygen has one lone pair of electrons. It involves resonance. At the same time, the ortho carbon gets the bonding electrons, pair of pi electrons, results in the formation of a resonating structure. So double bond O plus R. Again, so these electrons are involved in resonance. Para carbon accept a pair of pi electrons, so that this negative charge shifted to para position with respect to this alkoxide group to form another resonating structure. So the negative charge is formed on the para carbon atom to form, so here double bond O plus R. Again, these electrons are involved in resonance. So at the same time, this ortho carbon atom gets the pair of pi electrons to form one more resonating structure. So in this case, this ortho carbon atom also acquires a pair of pi electrons. Finally, so these electrons are also involved in resonance. We get the final resonating structure. The first and last structure, they are differ only in the position of carbon-carbon double bonds. So these two are also resonating structures. So these are all the resonating structures of alkyl aryl ethers. Resonating structures of alkyl aryl ethers. So nodile lone pair of electrons on the oxygen atom in alkyl aryl ethers, they are involved in resonance. So this is also electron donating group. So even when compared to alkyl group, there is it exerts a positive resonance effect, because the group or an atom having an unshared pair of electrons can donate these unshared pair of electrons towards the conjugated pi system. So therefore this alkoxide group, which can act as a that exerts a positive resonance effect. Is clear? So then another resonating structure is formed. Notice, so lone pair of electrons, it involves resonance. Ortho carbon atom with respect to this OR group gets a pair of pi electrons, so it acquires a negative charge. Means with respect to this OR group, it is electron rich center. Again, these electrons are involved in resonance. Para-carbon gains a pair of pi electrons so that it acquires negative charge. Is clear? So it means that this alkoxide group, which increases the electron density at ortho position, para position, again it is the ortho position. So therefore, during electrophilic substitution reactions of alkyl aryl ethers, means aromatic ethers, the electrophiles so preferably attached to the ortho positions or para positions. Is clear? So electrophiles, so hence electrophiles preferably attached to ortho and para positions. Why? Because ortho and para positions are rich in electrons. So because these ortho and para positions are, so because these are nucleophilic centers. So electrophiles are preferably attached to nucleophilic centers. Is it clear? So that is why when alkyl aryl ethers are subjected to electrophilic substitution reactions, the second incoming group to occupy either ortho position or para position, that results in the formation of ortho and para products. So ಹಾಗಾಗಿ ಇಲ್ಲಿ ಹಾಗಾದ್ರೆ ಯಾವ್ಯಾವ ಪ್ರಾಪರ್ಟೀಸ್ ಇದೆ ನೋಡೋಣ. ಕ್ಲಿಯರ್ ಅಲ್ಲಿ? ಇನ್ alkyl aryl ethers, alkoxy group is, it exerts positive resonance effect, which is means it is an electron donating group. So it increases the electron density at ortho and para positions. So therefore electrophiles are preferably attached to ortho and para positions. ಈಗ ಫಿನಾಲ್ ಅಲ್ಲಿ ಕೂಡ ಹಾಗೆ ಹೇಳಿದ್ನಲ್ವಾ. ಸೊ ಫಿನಾಲ್ ಅಲ್ಲಿ OH ಗ್ರೂಪ್ ಏನಿರುತ್ತೆ, ದಟ್ ಇಸ್ ಆಲ್ಸೋ electron donating group, that also increases. That is also the ring activating group that increases the electron density at ortho and para positions. So here also the alkoxide group, this is not H, so this is R. The alkoxide group, it is also ortho para directing group. So why? Because it increases the electron density at ortho and para positions. Is clear? So first property. So in case of electrophilic substitution reactions, so first property is bromination. So first one, bromination. So when anisole C6H5OCS3, this is anisole, which reacts with bromine in the presence of acetic acid. So it undergoes electrophilic substitution reaction. So this is the activating group which polarizes this bromine. So that is why here also no Lewis acid is preferred. Is clear? So that is why, so the hydrogen atom from ortho position and one bromine eliminated as HBr done. So Br attached to ortho position. This is called orthobromoanisole. Orthobromoanisole. Similarly, from the second molecule of anisole and from the second molecule of bromine, hydrogen atom from the second molecule of hydrogen atom from the para position with respect to this methoxy group from the second molecule of anisole, it is also replaced by bromine to form para-bromoanisole. So this is para-bromoanisole along with the formation of 2 moles of HBr, 1H, 1Br, again 1H, 1Br. So 2 moles of HBr. So what is action of anisole on bromine in acetic acid enter? So when anisole reacts with bromine in acetic acid medium, so here the bromine atom of the, so an electrophile is generated. So due to the presence of highly activating effect of this OCH3 group or methoxy group, it undergoes polarization so that electrophile Br plus is generated, that Br plus attacks to ortho position because ortho position is electron rich center. Similarly, so the bromine also attacks to para position. So among these two, this is the major compound. So because para products are always major compounds since they are the symmetrical structures. So what is the action of bromine on anisole? When anisole reacts with bromine in the presence of acetic acid medium to form orthobromoanisole and parabromoanisole. This is first property. Then second one is electrophilic substitution reactions. Second one, Friedel-Crafts reaction. Friedel-Crafts reaction. Second property, Friedel-Crafts reaction. Friedel-Crafts reaction. So both alkylation and acylation reaction or acetylation reaction. So when anisole, it is heated with methyl chloride or methyl iodide. So methyl chloride. So here methyl chloride. So hydrogen atom from ortho position and 1 Cl from methyl chloride. It is eliminated as HCl in the presence of anhydrous aluminum chloride. In the presence of anhydrous aluminum chloride, H is replaced by CS3 to form. So here OCS3, so here CH3. This is called first position, second position. So first preference will be given to alkyl group, second preference will be given to methoxy group. So 2-methoxytoluene. Then from the second molecule of anisole and from the second molecule of methyl chloride, hydrogen atom from para position, it is also replaced by methyl group to form 4-methoxytoluene. So here CH3, here OCH3 plus 2HCl to HCl. Is clear? Then methyl iodide ಅನ್ನು ಕೂಡ ಯೂಸ್ ಮಾಡಬಹುದು. methyl iodide. So methyl chloride or methyl iodide ಯಾವ್ದು ಬೇಕಾದ್ರೂ ಯೂಸ್ ಮಾಡಿರಲಿ. So in this case we get, so this is 1, 2, 3, 4. This is 4-methoxytoluene. So in this reaction, methyl group is introduced into the benzene ring of anisole. Hence it is called alkylation, methylation reaction. So when anisole is heated with methyl chloride in the presence of anhydrous aluminum chloride to form 2-methoxybenztoluene and 4-methoxytoluene. Nodi second position methoxy group is methoxy 6H5CH3 toluene. Or it is also called orthomethyl anisole, paramethyl anisole. ಅದು ಹಾಗೂ ಹೇಳ್ಬೋದು. Similarly, so when anisole is heated with acetyl chloride, so OCH3, this is anisole. So when anisole is heated with acetyl chloride in the presence of anhydrous aluminum chloride catalyst, so here also hydrogen atom from the ortho position and 1 Cl from acetyl chloride. This is acetyl chloride. So eliminated as HCl, then H is replaced by this acetyl group to form 2-methoxy. So OCS3. So here COCH3. Nodi ಇದನ್ನು OCH3 ಬಿಟ್ಟುಬಿಡ್ರಿ, C6H5COCH3, this is called acetophenone. Acetophenone. This is the first position. Second position, this is 2-methoxy acetophenone. 2-methoxy acetophenone. Similarly, from the second molecule of anisole and from the second molecule of acetyl chloride, so hydrogen atom from para position with respect to this methoxy group, it is also replaced by acetyl group to form 4-methoxy acetophenone. So OCH3 as it is. So acetyl group is introduced at the para position COCH3 plus 2 moles of HCl. So this is called, this is first position, second, third, fourth. This is called 4-methoxy acetophenone. 4-methoxy acetophenone. This is the 2-methoxy acetophenone. So this is an example for Friedel-Crafts acylation reaction. So when anisole is heated with acetyl chloride in the presence of anhydrous aluminum chloride, this acetyl group is introduced at the ortho and para positions, because we know that in alkyl aryl ethers, ortho and para positions are electron rich positions, nucleophilic centers. Hence these nucleophiles or electrophiles preferably attached to electron rich centers, results in the formation of both 2-methoxy acetophenone and 4-methoxy acetophenone. So among these two, this is the major compound. This is the major compound. Is clear? Similarly, so another properties. So when anisole, so the nitration reaction, nitration. So when anisole, C6H5OCH3, anisole, it is heated with nitric acid. In the presence of concentrated H2SO4. So this can be written as OHNO2. So look here. So this is anisole. Anisole means methyl phenyl ether. When it is heated with nitric acid HNO3, this can be written as OHNO2. So here also hydrogen atom from ortho position and one OH group from one molecule of nitric acid. Is clear? So one molecule of nitric acid. So it is eliminated as water. Then H is replaced by NO2 group to form two products. So one is ortho nitroanisole. So OCH3 here, NO2. So this is ortho nitroanisole. And second one is para nitroanisole. So NO2 group is substituted to both ortho and para positions. So here 2 molecules of anisole and 2 molecules of nitric acid are involved. Is clear? So when anisole, it is heated with nitric acid, it undergoes nitration. So NO2 group, so it attacks to the ortho position with respect to methoxide group, and also it attacks to para position with respect to methoxide group to form ortho nitroanisole and para nitroanisole. So ಈ ಪ್ರಾಪರ್ಟೀಸ್ ಕ್ಲಿಯರ್ ಆಯ್ತು. ಇದಾದರೆ ನಾನು ಇಲ್ಲೇ ಬರೀತೀನಿ. ಇಲ್ಲಿ ಅರ್ಥ ಆಯ್ತಲ್ಲ, ಇದು ಸೇಮ್ ಪ್ರಾಪರ್ಟಿ ನೋಡಿಲ್ಲಿ. ನೋಡಿಲ್ಲಿ, ಸೊ ಇದು ಕ್ಲಿಯರ್ ಆಗಿ ಗೊತ್ತಾಗ್ತಾ ಇದ್ರೆ ಇಲ್ಲಿ ನೋಡಿಲ್ಲಿ, ನೈಟ್ರೇಷನ್ ರಿಯಾಕ್ಷನ್, ಲಾಸ್ಟ್ ಪ್ರಾಪರ್ಟಿ ನೈಟ್ರೇಷನ್. ಸೊ ವೆನ್ ಅನಿಸೋಲ್ ಮೀನ್ಸ್ methyl phenyl ether. So this is anisole. When it is heated with nitric acid, HNO3, this can be written as OHNO2. OHNO2. This reaction is carried out in the presence of concentrated sulfuric acid. It is nitrating mixture. Is clear? Mixture of concentrated nitric acid and concentrated sulfuric acid is called nitrating mixture. So this is ortho position, it becomes electron rich. This H and OH group from one molecule of nitric acid eliminated as water to form ortho-nitro-anisole. So OCS3 as it is, NO2 group, this NO2 group attached to ortho position to form ortho-nitro-anisole. Ortho-nitro-anisole. Similarly, from the second molecule of anisole and from the second molecule of nitric acid, hydrogen atom from para position, it is also replaced by NO2 group to form para-nitro-anisole. So OCS3, here NO2. This is para-nitro-anisole. Para-nitro-anisole along with the formation of 2 moles of water. Along with the formation of 2 moles of water. So what happens when anisole, it is heated with nitrating mixture. So when anisole is heated with nitrating mixture, so nitro group from nitric acid, it attacks to ortho and para positions to form ortho-nitro-anisole and para-nitro-anisole. So these are the examples for electrophilic substitution reactions. So one is bromination, second one is Friedel-Crafts alkylation reaction, Friedel-Crafts acylation reaction, and nitration reaction. So these are the examples for electrophilic substitution reactions of anisole. So what is meant by anisole? Methyl phenyl ether. Innondide phenitol, ethyl phenyl ether. So isto ಆಲ್ಕೋಹಾಲ್ಸ್ ಫಿನಾಲ್ಸ್ ಈ ಥರ್ಸಲ್ಲಿ ಬರ್ತಕ್ಕಂಥ ಪ್ರಿಪರೇಷನ್ಸ್ ಮತ್ತು ಪ್ರಾಪರ್ಟೀಸ್. ನಾವು ಇಲ್ಲಿ ನೀವು ಥಿಯರಿಟಿಕಲ್ ಪಾರ್ಟಲ್ಲಿ ಇಷ್ಟು ನೀವು ಕ್ಲೀನಾಗಿ ಕೇಳಿದರೆ ನಿಮಗೆ ಕಾಂಪಿಟೇಟಿವ್ ಪಾರ್ಟ್ ವೆರಿ ಈಸಿ. ನೀವು ಇಷ್ಟು ಕರೆಕ್ಟಾಗಿ ವರ್ಕ್ ಮಾಡಿ ಕರೆಕ್ಟಾಗಿ ಕಲ್ತು ಬಿಡ್ರೆ ಏನು ಬೇಕಾಗಿಲ್ಲ. ಅಡಿಷನಲ್ ಪಾಯಿಂಟ್ಸ್ ಇನ್ನು ಯಾವುದಾದ್ರು ಇದ್ದರೆ ಬೇಕಾದ್ರೆ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಕಾಂಪಿಟೇಟಿವ್ ಪಾರ್ಟಲ್ಲಿ ಹೇಳ್ತೀನಿ. ಸೊ ಅರೌಂಡ್ 180 ಕ್ವೆಶನ್ಸನ್ನು ನಿಮಗೆ ಕಳಿಸ್ಕೊಡ್ತಾ ಇದ್ದೀನಿ. ಆ 180 ಕ್ವೆಶನ್ಸ್ ಕೂಡ ಇದರಲ್ಲೇ ಇರುತ್ತೆ ನಿಮ್ಮ ಆ್ಯಸ್ ಪರ್ NCERT. ಅದು ಕರೆಕ್ಟಾಗಿ ಥರೋ ಆಗ್ರಿ. ಇದು ಕ್ಲಿಯರ್. ಸೊ ಅದ್ರಲ್ಲಿ ನಾನು ಸೆಲೆಕ್ಟ್ ಮಾಡಿಕೊಂಡು ನಿಮಗೆ ಇರ್ರಿಲೆವೆಂಟ್ ಅಂತಕ್ಕಂಥವು, ಇರ್ರಿಲೆವೆಂಟ್ ಅಂದರೆ ಆ ಸಬ್ಜೆಕ್ಟ್ ರಿಲೇಟೆಡ್. ಸೊ ಅದರಲ್ಲಿ ಸ್ವಲ್ಪ ಕಾನ್ಸೆಪ್ಟ್ ಡೈವರ್ಟ್ ಆಗಿರತಕ್ಕಂಥವು ಏನಿದಾವಲ್ಲ, ಸೊ ಅವನ್ನ ನಾನು ಡಿಸ್ಕಸ್ ಮಾಡ್ತಾ ಬರ್ತೇನೆ. ಉಳಿದವನ್ನ ನಿಮಗೆ ಡೈರೆಕ್ಟ್ ಇರ್ತಕ್ಕಂಥವು ನೀವು ಅವ್ನು ನೋಡ್ಕೊಂಡು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡ್ಕೋಬೇಕು ಅಲ್ವಾ. ಸೊ ಆ ಮೆಟೀರಿಯಲ್ ಜೊತೆಗೆ ನೀವು ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಕೂತ್ಕೋಬೇಕು. ಸೊ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸ್ ನೀಟ್ ಕ್ಲಾಸ್ ಮತ್ತು JEE. ಸೊ ಇಲ್ಲಿ ನೀವು ಈ ಥಿಯರಿ ಪಾರ್ಟ್ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಿಗೆ ನಾಳೆ ಬರುವಾಗ ಕಂಪ್ಲೀಟ್ ಇದನ್ನೆಲ್ಲ ಪಕ್ಕ ಒಂದು ಸರಿ ರಿಕಾಲ್ ಮಾಡಿಕೊಂಡು ರಿವಿಷನ್ ಮಾಡಿಕೊಂಡು ಚೆನ್ನಾಗಿ ವರ್ಕ್ ಮಾಡಿ ನೀವು ಅಲ್ಲಿ ಕಾಂಪಿಟೇಟಿವ್ ಪಾರ್ಟಲ್ಲಿ ಕೂತ್ರೆ ಈಸಿಯಾಗಿ ನಿಮಗೆ ಗೊತ್ತಾಗುತ್ತೆ. ಓಕೆ. ಸೊ ಈ ಕಾಂಪಿಟೇಟಿವ್ ಪಾರ್ಟನ್ನು ಮುಗಿಸಿ ನೆಕ್ಸ್ಟ್ ಇನ್ನೊಂದು ಟಾಪಿಕ್ ಬರೋಣ ಅಂತ. ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ಗೊತ್ತಾಯ್ತಲ್ಲ, ಇದೊಂದು ಸರಿ ಕಂಪ್ಲೀಟ್ ರಿವಿಷನ್ ಮಾಡಿಕೊಂಡು ನೀವು ಕಾಂಪಿಟೇಟಿವ್ ಪಾರ್ಟಲ್ಲಿ ಕರೆಕ್ಟಾಗಿ ಕೂತಿರ್ಬೇಕು, ಮೆಟೀರಿಯಲ್ ಇಟ್ಕೊಂಡು ಕೂತಿರ್ಬೇಕು. ಗೊತ್ತಾಯ್ತಾ? ಇಲ್ಲಿ ಥಿಯರಿ ಪಾರ್ಟ್ ನಿಮ್ಗೆ ಅರ್ಥ ಆಯ್ತು ಅಂದರೆ ಅಲ್ಲಿ ಭಾಳ ಈಸಿ ಆಗುತ್ತೆ, ಏನು ಕಷ್ಟ ಆಗೋದಿಲ್ಲ. ಇಸ್ ಕ್ಲಿಯರ್? ಸೊ ಹಾಗಾದರೆ ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲೇ ವಿತ್ ಮೆಟೀರಿಯಲ್ ಕೂತಿರ್ತೀರಿ, ಒಂದು ಸರಿ ರಿವಿಷನ್ ಮಾಡ್ಕೊಂಬರ್ರಿ. ನೆಕ್ಸ್ಟ್ ಕ್ಲಾಸಲ್ಲಿ ನೀಟ್ ಆ್ಯಂಡ್ JEE ಕ್ಲಾಸನ್ನು ಕಂಟಿನ್ಯೂ ಮಾಡೋಣ. ಓಕೆ, ಥ್ಯಾಂಕ್ ಯು.